At 2:55 in the afternoon on May 29, 2026, the China Earthquake Network Center recorded a magnitude 5.0 seismic event beneath Toksun County in Xinjiang's Turpan city, a rupture originating at a focal depth of exactly 20 kilometers, placing its origin point not at the surface where the ground cracks, and the walls shake but deep in the crust where faults do not warn anyone before they move. The epicenter was logged at approximately 5 kilometers southeast of Kumux Township, 76 kilometers from the county seat of Toksun, 121 kilometers from Turpan City, and 184 kilometers from Urumqi, the regional capital. Strong tremors were felt immediately in Kumux. Shaking was reported as far away as Urumqi itself. The instruments were not approximating. The instruments were measuring, and what they measured is not a footnote in the day's news cycle. It is the latest signal from a fault system that has been building towards something far larger for longer than recorded human history in this region. If you rely on this channel for science-grounded and verified data and explained with honesty, subscribing ensures that none of this reaches you late. This work depends on the audience that values it. Every figure in this script was drawn from official scientific and governmental sources: the China Earthquake Network Center, Xinhua, CGTN, the USGS ANTS Comcat database, peer-reviewed seismological research published in journals including Science Direct and Nature, and the Smithsonian Global Volcanism Program, but official sources are not infallible, and neither is the human process of reading them. Before any decision is made, whether personal, professional, or otherwise, verify independently through the official channels. The sources are listed, the data is public, the responsibility to check belongs to all of us, but that is not even the complete picture. The earthquake that struck Toksun County today is not, on its own, what seismologists would classify as a major event. A magnitude 5.0 at 20 kilometers depth is felt. It shakes buildings. It sends rescue teams scrambling to their vehicles. It prompts emergency monitoring agencies to stand their personnel at readiness, but in a purely numerical sense, it is survivable. The Turpan Fire and Rescue Detachment deployed 9 vehicles, 30 personnel, and 1 search dog, traffic, power supply, and telecommunications. In Toksun County were reported unaffected. No casualties were confirmed. And yet the scientists who study this particular corridor of the planet, the fold and thrust belts of the eastern Tien Shan mountain system where Toksun County sits, do not look at a magnitude 5.0 here and relax. They look at it and pay attention. Because what lies beneath Toksun County, beneath the Turpan Depression, beneath the overlying sedimentary basins that have absorbed the shock of today's event and will absorb the shock of whatever follows, is a tectonic inheritance so vast and so unresolved that calling today's earthquake a small one requires knowing exactly what it is small in comparison to, and once you know that, the word small stops being available. The Tien Shan mountain belt, Tien Shan in Mandarin, meaning heavenly mountains, is one of the most seismically active continental mountain systems on Earth. It runs approximately 2,500 kilometers from Uzbekistan in the west through Kyrgyzstan and into China's Xinjiang region in the east. It rises to peaks exceeding 400 meters, but its importance to the science of seismology is not its height, it is what is happening beneath it. The Tien Shan is the product of a collision that began roughly 50 million years ago and has not stopped. The Indian plate, driving northward at a rate of approximately 40 to 50 millimeters per year, struck the Eurasian plate and began compressing it. The Himalayas rose from that collision. The Tibetan plateau thickened from that collision. And the stress, the immeasurable gravitational and mechanical stress of 2 continental masses pressing against each other across a front thousands of kilometers wide, transmitted itself northward into the heart of Central Asia, reactivating ancient fault systems that had been quiet for hundreds of millions of years and bending the crust into the east-west corrugated ridges and basins that define the landscape of Xinjiang today. The Turpan Basin, where Toksun County sits, is one of those basins. It lies more than 150 meters below sea level at its lowest point, the second lowest land surface on Earth. It exists because the crust on either side of it was forced upward while the basin floor was simultaneously pulled down. It is, in the most literal geological sense, a scar, and the faults that created it are not healed. Scientific research published in peer-reviewed journals characterizes the epicentral region around the eastern Tien Shan as dominated by numerous east-northeast trending reverse faults and left lateral strike-slip faults, with intermontane basins compressed between active thrust structures. The north-south shortening rate across the Tien Shan decreases from approximately 20 millimeters per year in the west to less than 5 millimeters per year in the east, according to GPS geodetic data. 5 millimeters per year, the width of a human fingernail across an entire year, that is the compression rate, but 5 millimeters of crustal shortening every year, accumulated over decades without a full release, is not nothing. It is stored energy, it is a system accumulating, and what the data shows clearly is that this system has released catastrophically before, with consequences the geological record preserves in complete and unambiguous detail. Consider the people of Kumux Township today. Kumux is a settlement in the arid interior of Toksun County, a place where the land is pale brown and the summer heat exceeds 47 degrees Celsius, where the wind comes through the mountain passes with enough force to strip dust from the plateau surface and carry it for hundreds of kilometers. The population of Toksun County as A hole is recorded at 134,235 people, of whom approximately 76.5% are Uyghur. The urban population of the county seat itself is roughly 36,891. These are communities built on desert floor at the intersection of ancient Silk Road trade routes, communities where families have lived in the same valleys for generations, where the afternoon trembling of the earth at 2:55 today was not an abstraction but a physical event, walls vibrating, dust falling from ceiling joints. Children looking up from schoolwork, elders pausing and waiting, as people who have lived on active ground always pause and wait for the shaking to tell them how serious it is this time. The rescue team from Toksun County dispatched 2 vehicles and 10 personnel immediately to the epicenter. That detail matters. It means that the local response infrastructure treated this earthquake not as a minor statistical event, but as the first observable fact of a potentially larger sequence. They went to look. That is what you do when the ground moves in a place like this. You go to look, because what you find in the first hours after a moderate earthquake in the Tien Shan can determine how prepared you are for what may come in the next hours or the next days. Here is where this account becomes genuinely significant. The magnitude 5.0 event in Toksun County today did not occur in a seismic vacuum. It occurred in a region that has produced some of the largest continental earthquakes ever recorded anywhere on Earth. The geological and seismological literature is unambiguous on this point. Since the year 1900, the broader Tien Shan system has generated at least 11 earthquakes of magnitude 7.0 or greater, 11 events of that scale in approximately 125 years, and the largest of them were not modern events that benefited from early warning systems and reinforced infrastructure. They were events that struck communities with no preparation, no monitoring, and no realistic capacity to recover. On August 22, 1902, a thrust earthquake measured at magnitude 7.7 and in some seismological databases recorded as high as 8.6 on the surface wave scale struck the Tien Shan Mountains near what is now the Artsakh area of Xinjiang, close to the Kyrgyzstan border. The depth was 18 kilometers. The epicentral intensity reached the maximum recorded level on the Russian seismic intensity scale of the era. Between 5,650 and 10,000 people were killed. At least 30,000 homes were destroyed. Aftershocks continued to be recorded for 3 years. The largest aftershock reached between 6, 8, and 7.3 in magnitude. A smaller aftershock sequence continued for more than a decade after the main shock. This is not a hypothesis. This is documented in the geological record, in the instrumental record, and in the historical record of communities that ceased to exist in the hours following that rupture. The 1902 Artsakh earthquake remains one of the most destructive continental thrust events ever recorded in Central Asia, and the fault system responsible for it, the fold and thrust belt of the Tien Shan, is the same fault system that moved beneath Toksun County at 2:55 this afternoon, 9 years after Artsakh. On January 3, 1911, the Kebun earthquake struck at magnitude 8.2. On December 23, 1906, the Manas earthquake reached 7.7. On July 11, 1889, the Chiluk earthquake reached 8.3. These are not isolated curiosities. They are data points in a pattern of major rupture along the Tien Shan system at intervals measured not in centuries but in decades. The scientific literature on Coulomb stress transfer in this region documents clearly how each large event redistributed stress onto adjacent fault segments, how the 1902 Artsakh earthquake increased stress levels by more than 100 kilopascals in areas that subsequently ruptured in the following decades. Stress does not dissipate after an earthquake, it transfers. It moves to the next locked section of fault and presses against it until that section either creeps slowly forward or breaks suddenly. The question is not whether this transfer is occurring. The question is when the next receiving fault reaches its threshold. In January 2024, just over 2 years ago, the region delivered another answer, a magnitude 7. One earthquake struck Turpan County, also in Xinjiang, at 2:09 local time on January 23rd. The focal depth was 13 kilometers shallower than today's Toksun event, which makes the shaking more violent at the surface. The epicentral intensity reached level 9 on the China seismic intensity scale, a level at which most unreinforced masonry structures are critically damaged. 3 people were killed in Xinjiang. 74 were injured across China, Kazakhstan, and Kyrgyzstan. At least 93 buildings collapsed in the Kyzyl-Su Kyrgyz Autonomous Prefecture. An additional 851 were damaged. 18,346 people were displaced across Xinjiang, the Chinese government. Estimated total damage at 3.79 billion yuans, more than $527 million US, and the aftershock sequence generated more than 4,200 recorded events, of which 9 reached or exceeded magnitude 5.0 on the moment magnitude scale. The fault involved was a thrust structure within the same fold and thrust belt that controls seismicity. In the Toksun area, the system was not inactive in 2024. The system is not inactive today. The Turpan-Hami Basin, the broader geological structure within which Toksun County sits, is bounded to the north by the Bogda Shan Range and to the south by the southern Tien Shan Ranges. It is a tectonically compressed intermontane basin, which means it's between active mountain building structures that are continuing to converge. The basin floor where communities live and farm is underlain by sedimentary sequences, thousands of meters thick sequences that amplify seismic waves, that translate the motion of a deep fault rupture into longer period shaking that feels slower, more rolling, and that can do far more damage to multi-story buildings than the sharp, fast shaking of a shallow event, the focal depth of today's M5.0 was 20 kilometers deep enough that the shaking at the surface was broad rather than sharp, but the sedimentary basin amplification means that even a moderate event at this depth can generate surface motion considerably more intense than a comparable earthquake in hard rock. The science of site amplification is well established. The Turpan Depression is, by its geological nature, a natural amplifier. Think about what 20 kilometers means in human terms. Stand anywhere on the surface of Toksun County, look down. The rupture that occurred today at 2:55 in the afternoon was taking place at a point directly beneath your feet that is so far underground it would take you nearly 6 hours to reach at a fast walking pace. Assuming the rock was not in the way, which of course it is, 20 kilometers of crust, compressed, stressed, heated by the Earth's internal heat, traversed by fluids that alter the mechanical behavior of rock, cut through by fault planes that have been accumulating stress for decades. That is what moved this afternoon, not a stone you could hold, not a wall that cracked. The foundation of the continental crust itself, releasing a fraction of the energy that has been building within it since the last time this particular section of fault slipped. Now consider the connected systems. The seismicity of the Tien Shan does not operate in isolation from the rest of the planet's mechanical behavior. The stress field that drives fault rupture in Xinjiang is the direct product of the India-Eurasia collision, a collision that is simultaneously building the Himalayas, driving the eastward extrusion of the Indochina block, thickening the Tibetan plateau, and transmitting compressional stress northward into the Tien Shan system at rates measured by satellite geodesy to extraordinary precision. GPS data confirms that the Tarim block, the rigid crustal unit that underlies the Tarim basin south of the Tien Shan, is moving northward relative to stable Eurasia at approximately 20 millimeters per year in the western part of the range. This ongoing convergence means that the fault systems of the Tien Shan are not occasionally loaded by distant tectonic events. They are continuously loaded every year, every decade. The loading never pauses. The question is purely one of when individual fault segments reach their failure threshold and rupture. There is a second connected system that deserves precise attention. Xinjiang has experienced intensifying climate stress over the past several decades, with measurable increases in both mean temperature and precipitation variability. The glaciers of the Tien Shan, some of the largest mountain glaciers outside the polar regions, are retreating at documented rates. Glacier retreat is not merely a climate statistic. When large volumes of ice are removed from mountain systems, the reduction in glacial load changes the stress distribution on underlying fault systems. This is a documented geophysical phenomenon. Glacial unloading alters the normal stress on fault planes, potentially bringing previously stable fault segments closer to their failure thresholds. Research from Scandinavia and Alaska has quantified this effect following post-glacial rebound. The Tien Shan glaciers are not yet at the extreme loss stage, but the trend is directional and measurable, and it is operating on a fault system that is already under the highest tectonic stress in continental Asia. These two loading mechanisms, tectonic compression from the Indian plate collision and progressive glacial unloading from climate-driven ice loss, are not independent variables. They are additive pressures on the same geological system. That the system produces a magnitude 5.0 today is not surprising to seismologists who monitor this region. What they watch for, and what the data from events like today's reinforces, is whether the pattern of moderate seismicity represents a gradual, distributed release of accumulated stress, which would be the benign interpretation, or whether it represents the early indicators of a fault segment approaching catastrophic failure. The instruments can measure the former, they cannot reliably predict the latter. Now bring the science back to the ground, back to the 134,235 people of Toksun County, back to the family in Kumux Township who felt their walls move this afternoon and did not yet know that a rescue team was on its way, back to the residents of Turpan City, 121 kilometers from the epicenter, who felt the shaking and checked their buildings and called their relatives. Back to the people of Urumqi, 184 kilometers distant, who felt enough ground motion to notice and who now live in a city of more than 4 million people sitting in a tectonically active basin with known seismic hazard, a city that has grown with extraordinary speed over the past 3 decades, a city whose older building stock was not engineered to the seismic standards that the data about this region demands for million people in Urumqi. 134,000 in Toksun County alone. The question those people would ask, if they were sitting with the data in front of them right now, is the same question any rational person asks when the ground beneath them has just moved. Is this the event, or is this the warning before the event? And the honest answer, the scientifically grounded, officially supported, rigorously defensible answer, is that the instruments cannot tell them. Not yet, not with current technology, not with any confidence that would allow a responsible scientist to issue an all clear. This is not a hypothesis. This is documented in the geological record, in the instrumental catalogs maintained by the China Earthquake Network Center, and in the peer-reviewed literature that has studied this region's seismicity for decades. The Tien Shan system has produced magnitude 8 or greater events in 1889, 1902, and 1911. It produced a magnitude 7.1 event in 2024 that displaced nearly 19,000 people and caused more than $500 million in damage. Between those large events, the record is not quiet. It is filled with moderate events, magnitude 4, magnitude 5, magnitude 6 events that represent the ongoing adjustment of a fault system under continuous loading. Today's magnitude 5.0 in Toksun County is one of those adjustments. Scientists choose their language. Carefully here, a moderate earthquake in an actively loading fold and thrust belt is not a safe event. It is an informative event. It tells the monitoring agencies something about where stress is concentrating. It tells the emergency management authorities that this segment of the fault system is capable of rupture. It tells the population within its reach that the ground beneath them is not stable in any geological timescale, and it tells the researchers who study the Coulomb stress transfer between adjacent fault segments that the stress budget of this part of the Tien Shan system has been partially, but only partially, adjusted. There is a further dimension to this account that demands attention. The Toksun area sits within the broader Turpan-Hami Basin tectonic framework, where the Bogda Mountain thrust system to the north interacts with the southern Tien Shan thrust belt. Geological research on the basin structure identifies the Toksun Depression specifically as a sub-basin that developed as a consequence of differential subsidence driven by active faulting at the basin margins. This means that the sedimentary record of the Toksun area is itself a seismic archive, layers of silt and sand deposited in a basin that has been subsiding in direct response to faulting activity for millions of years. Every earthquake in the geological past of this region has left its signature in those sediments. Core samples from lakes in the broader Xinjiang region, analyzed by researchers at Chinese and international universities, have identified at least 8 major seismic events preserved in sedimentary sequences going back 32,000 years. 8 confirmed major ruptures over 32 millennia, suggesting recurrence intervals measured in thousands of years for the largest events, but recurrence intervals that have clearly been reached before, and that the current state of tectonic loading suggests may be approaching again in some segments of the system. The data is not precise on timing. The data is precise on the fact that this has happened before and that the conditions that produce those past events remain fully active today. The monitoring is in place and detection is possible, but prediction is not. That sentence, stated plainly in the language of operational seismology, is the most important thing the data supports. China's seismic monitoring network, operated through the China Earthquake Network Center, the provincial earthquake administrations, and integrated with international monitoring systems, is one of the densest in the world in tectonically active regions. The instruments detected today's M5.0 within minutes of its occurrence. The focal depth was calculated, the epicenter was located to within kilometers. The emergency response was initiated within the hour. This is the best outcome that modern seismic monitoring can offer: rapid detection, rapid location, rapid response. What it cannot offer, what no monitoring system on Earth currently offers, is advance warning of when the next large event will occur, how large it will be, or which specific fault segment will host it. The science is honest about this. Scientists who study the Tien Shan are honest about this. The question is not whether the system will produce another major earthquake. The question is when, and the geological record offers a range of answers measured not in years but in decades. That range includes today, that range includes tomorrow. Return one final time to the specific human reality embedded in today's event. The 10-person rescue team that drove toward the epicenter of this morning's earthquake did not know what they would find. They drove across an arid landscape toward a location 5 kilometers southeast of Kumux Township, toward a point directly above a fault rupture that had released, in approximately the span of a few seconds, energy equivalent to dozens of times the force of the atomic weapon used at Hiroshima at the scale of a moderate earthquake, which is precisely what today's event was. A magnitude 5.0 releases approximately 31.6 times the energy of a magnitude 4.0, and the ground responded to that energy by transmitting it upward through 20 kilometers of crustal rock into the sedimentary fill of the Turpan Basin and out through the surface as the rolling, multi-second shaking that residents of Kumux Township, Toksun County, Turpan City, and Urumqi felt in the afternoon of May 29, 2026. No casualties confirmed. No disruption to infrastructure confirmed, but a rescue team was dispatched anyway, because experience in this region demands that assumption never precede observation. You go and you look. And when the instruments show you that a fault 20 kilometers beneath a densely instrumented but sparsely populated desert basin has just moved, and when you know because the geological record tells you with complete clarity that this same fault system produced earthquakes of magnitude 7, 7, and 8, 6 in the past 125 years, you do not look at today's M5.0 and conclude that the system has relaxed. You look at it and understand that the system is active, that it is accumulating, and that the only honest thing science can say about what happens next is that the instruments will tell you when it begins, not before. The Turpan Basin has been below sea level for millions of years. The faults that hold it down and push the mountains above it upward have been moving for 50 million years. The Indian plate will not stop its northward drive in any time frame relevant to human civilization. The fold and thrust belt of the Tien Shan will continue to shorten. The fault segments that have not ruptured in recent decades will continue to accumulate the stress transferred to them by the events that have And somewhere in Kumux Township tonight, in a building that felt the walls tremble at 2:55 this afternoon, someone is listening for the next sound the ground makes aware, as people who live on active faults are always aware that what the Earth has stored, the Earth will eventually spend, the last magnitude 8 earthquake. In this fault system struck before the first airplane ever flew. The youngest people who survived it have been dead for generations. And yet the rock that ruptured that day remains under the same stress it was under the moment before it failed, because the Indian plate has not stopped, and the Tien Shan has not finished rising, and the instruments placed in the ground of Xinjiang today are measuring right now the slow and patient accumulation of exactly the kind of energy that once, on an August morning in 1902, ended 10,000 lives before anyone had time to run,